Lesson 2.3, solving inequalities by multiplying or dividing. So very similar to equations when we have multiplication or division, we do the inverse operation to isolate our variable by itself to solve our inequality. So the same rules apply for solving equations. What you do to one side, you do to the other. So for multiplication, you can multiply both sides by the same sign. Division, divide both sides by the same thing, and it'll keep your inequality balanced. Now, there's something that will come into play when we deal with negative numbers, which we'll look at in a little bit. But positive numbers do the same thing to both sides, nothing changes. But once negative numbers start to come in play, we'll have to do just one quick little thing to keep our inequality true. So we're going to start with example 1. We're going to solve each inequality and then graph the solutions. So first we have 3x is greater than negative 27. So we're going to divide both sides by 3. 3 divided by 3 is 1, so I'm left with x. Negative 27 divided by 3 gives me negative 9. So x is greater than negative 9 is my answer, and then I'm going to graph it. So on my number line, I'm going to have negative 9, negative 8, negative 7, negative 10, negative 11. So x is greater than negative 9. Greater than means I'm going to have an open dot at our important number, which is negative 9. So open dot. And then x is greater than, so I need numbers bigger than negative 9, which is going to be to the right. So I'm shading to the right. So I'm shading to the right, and then I'm going to draw my arrow. All right. B, we have 2/3 r is less than 6. So for this one, we're going to multiply both sides by the reciprocal, which is 3 over 2. So 3 over 2. I'm going to write this 6 over 1 so we can simplify over there. Okay, 3 divided by 3 is 1. 2 divided by 2 is 1, so I'm left with just 1 r. Less than, 6 and 2 are both divisible by 2. 6 divided by 2 is 3. 2 divided by 2 is 1. And then I multiply across. 3 times 3 is 9. 1 times 1 is 1. 9 over 1 is 9. So we have r is less than 9. And then I'm going to graph my answer. So I'm going to have 9, 10, 11, and then the other way, 8 and 7. I have less than, so I'm going to have an open dot at 9. And then less than, I want numbers smaller than 9, so like 7 and 8. So I'm shading to the left here. So shading to the left, and then I'll draw my arrow. That's example 1. There are 3 check it out problems for you to try, so go ahead, take a moment, pause the video, and try these 3 on your own. So you're going to solve them and then graph them. Resume the video when you're ready to check your answer. Okay, for the first one, 4k is greater than 24. I'm going to divide both sides by 4. Okay, 4 divided by 4 is 1, so I'm left with k. 24 divided by 4 gives me 6. So I get k is greater than 6. So I'm going to draw my number line. I'm going to have an open dot at 6, and then I'm shading to the right. And with these, you might have done different scaling than me. You could have counted up by 2s. Or maybe you wanted to do halves. That's fine. As long as your dot is on the same number and it's open, shading to the right. For B, I'm going to divide both sides by 5. Negative 50 divided by 5 gives me negative 10. Greater than or equal to 5 divided by 5 is 1, so I'm left with Q. And then I need to rewrite this, so I'm going to flip-flop the order, so Q comes first. So Q is less than or equal to negative 10. And now I'll graph my solution. So I have negative 10, and then I'll put negative 9, negative 11. So it's less than or equal to, so I'm going to have a closed dot because it's equal to at negative 10. And Q is less than, so I shade to the left. And then I draw my arrow. For C, I have 3/4 G is greater than 27. So to make 3/4 1, I'm going to multiply by the reciprocal, so 4 over 3, and I do the same thing to the other side. I'm going to put 27 over 1 so I can simplify then. 4 divided by 4 is 1, 3 divided by 3 is 1. So I'm left with G. Then I have greater than 27 and 3 are both divisible by 3. So I'm going to start by doing 27 divided by 3, and that gives me 9. 3 divided by 3 is 1. So then I have 9 times 4, which gives me 36, and then 1 times 1 is 1. So I have 36 over 1, which is just 36. So G is greater than 36. So then last I just need to graph this last one. So I have 36, 37, and then 35 below. I'm greater than, so I'm going to have an open dot on 36. And then I want numbers bigger than 36, so I'm going to shade to the right. So those are your answers to the check it out problems. So far, we have been looking at multiplying and dividing by positive numbers. So we want to know what happens when you multiply or divide both sides of an inequality by a negative number. So here's what happens. So 2 is less than 6 is a true statement. If I multiply both sides by negative 1, I get negative 2 and negative 6. Well, what's bigger, negative 2 or is negative 6? Well, negative 2 is bigger, so negative 2 is greater than negative 6. So my sign, my inequality sign, switched. Let's look at another one. 6 is greater than negative 2. Let's multiply by negative 1. 6 becomes negative 6. Negative 2 becomes positive 2. Now the 2 is bigger than negative 6. So you probably noticed when you multiply up here, and also when you divide both sides of an inequality by a negative number, you must reverse the inequality sign. So greater than becomes less than becomes greater than. Same thing with the equal to. This means there is another set of properties of inequalities for multiplying or dividing by a negative. So if you multiply both sides of an inequality by the same negative number, you must reverse the inequality symbol for the statement to still be true. So if I multiply both sides by negative 2, the greater than then becomes less than. Same thing with division. If you divide by a negative, you flip the sign. Okay? And it's also true for all of our inequality symbols. Okay? So let's look at example 2. So for A, we have negative 8x is greater than 72. So I need to divide both sides by negative 8. Negative 8 divided by negative 8 gives me 1, so I'm left with 1x. I need to flip my sign. And then I do 72 divided by negative 8, which gives me negative 9. So x is less than negative 9. So if you divide or multiply by a negative, your sign flips. So now I'll graph my solutions. So I have negative 9, negative 8, negative 7, negative 10, negative 11. I'm less than, so I'm going to have an open dot at negative 9, and then I shade to the left. B, I have negative 3 less than or equal to x divided by negative 5. So I have to multiply by negative 5 on both sides. Negative 5 times negative 3 gives me a positive 15. I flip my sign, so I have greater than or equal to. And then if I put this over 1, negative 5 divided by negative 5 gives me 1. So I'm left with x over 1, which is just x. So 15 is greater than or equal to x. And then I should flip-flop my order. So I'm going to have x is less than or equal to 15 for my inequality. And then I'll go and graph. So we have 15, 16, 17, 14, 13. So I have less than or equal to, so I have a closed dot or a solid dot at 15, my important number, and then I shade to the left. Okay, so that is example 2. So now we're going to have a check it out problem. There's 2 of them for you to try. So go ahead, pause the video, try these 2 on your own, and then resume the video when you are ready. Let me try to get the focus back so you can see this. There we go. All right, so go ahead and solve these 2 problems. So for A, we have 10 is greater than or equal to negative x. So for here, I'm going to divide both sides by negative 1 because this is a negative 1x. 10 divided by negative 1 is negative 10. Flip my sign, and then I have x. And then to write my final answer, I'm just going to reorder it, have the x come first. So x is greater than or equal to negative 10. And then I'll graph my solution. So we have negative 10, negative 9, and then negative 11 to the left. So greater than or equal to, so I have a closed dot on negative 10, and I shade to the right. And then I'll draw my arrow. To B, I have 4.25 is greater than negative 0.25h. So I'm going to divide both sides by negative 0.25. 4.25 divided by negative 0.25 gives me negative 17. I flip my sign. And then negative 0.25 divided by negative 0.25 is 1. So I'm left with h. So h is greater than negative 17. And then I will draw my graph. Oops, that should be, I apologize, that should be negative 16. Over here should be negative 18. So then I am greater than, so I'm going to have an open dot at negative 17, and I shade to the right. And then I draw my arrow. So that is the answer to those 2 check it out problems. Example 3. It says Ryan has a $16 gift card for a health store where a smoothie costs $2.50 with tax. What are the possible numbers of smoothie that Ryan can buy? So we know we have a $16 gift card. Smoothies cost $2.50 each. So here, you're going to have to set a variable for the number of smoothies Ryan can buy. So they picked S in the book. You can pick any letter that you want unless they tell you have to use a specific letter. So S represents the number of smoothies Ryan can buy. So it's going to be $2.50 times the number of smoothies is at most 16 because we can't spend more than $16. We can spend exactly $16 but no more. So it's going to be $2.50 times S is less than or equal to 16. So do $2.50 less than or equal to 16. Divide both sides by $2.50. $2.50 divided by $2.50 is 1, so I'm left with S. And then less than or equal to 16 divided by $2.50 gives you 6.4. Now we don't switch the sign because we were dividing by a positive. Okay, the only time you switch the sign is when it's a negative. So we have S is less than or equal to 6.4. But remember, you can only buy a whole number of smoothies. You can't buy a half a smoothie or a quarter of a smoothie. So here, when we go to answer, we can only answer in whole numbers. So 6.4, less than that, so you could do 6, 5, 4, 3, 2, 1, or 0. So Ryan can buy 0, 1, 2, 3, 4, 5, or 6 smoothies, but no more than 6, okay, because he doesn't have enough money. There's a check it out problem for you to try. It says a pitcher holds 128 ounces of juice. What are the possible number of 10-ounce servings that one pitcher can fill? So go ahead and pause the video, try this problem on your own, and then resume when you are ready. So we have 128 ounces, and we're doing 10-ounce servings. So we're going to have an inequality of 10x has to be less than or equal to 128. So then from here, we can divide both sides by 10. 10 divided by 10 is 1, so I'm left with x. X is less than or equal to 128 divided by 10 will give me 12.8. Okay? And when we talk about servings, we talk about them in whole numbers. So we can have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, or 12 servings. Oops. 12 servings. Okay, we can't have more than 12. We can't do 13 because 13 would be bigger than 12.8. Okay?